Hello and welcome to another video on the Luger system. In this video, I'm going to be discussing qualitatively discussing the dynamics of the motion of the upper relative to the frame. By the upper, I mean the barrel extension, and the toggle train, including the breech board. So when a round is fired, once the bullet leaves the muzzle, this whole upper starts to retract backwards. Now, this retraction, there's about 10.5 millimeters for the barrel extension to move back before it is stopped by the receiver log, stop log, and then this point of the log here, okay, I zoomed a little bit, okay, this point here hits the frame over here, okay. Now, surprisingly, the collision marks are really not that significant. And that's basically talking about looking at several, actually a couple of dozen Lugers in my collection. There is really no pronounced stoppage or collision mark on this area of the frame. This happens to be a model 1908 Bulgarian, and the same would be true for a 1911 chambered DWM. There's barely any mark of collision there, and similarly for a model 1900 American Eagle. Now, there are four collisions that happens with varying degrees of intensity, if you like. There's this the two due to the receiver's stop log, which is one here, and one when the upper moves forward all the way. This part of the log is going to hit over here, and in fact, this one has visible, okay, you can see some visible marking of the collision itself. I don't know if we can see it good here, but it is there. I would say that is more pronounced, relatively speaking, this collision than this collision of the back of the log with the frame. Now, the two remaining collisions are the one that's well known when the bottom tail of the rear toggle hits the frame, and that would be vary in intensity, the degree of the marking. That depends on how. This is Bulgarian. It's really there, really visible. It depends on the mainspring and how many rounds have been put, through the gun. Is the gun well lubricated or not, and all that. Because if the gun is not well lubricated and still it cycles properly, they'll have added friction, and that friction would be basically energy lost, which is going to reduce the severity of this collision, okay, at the end of recoil. All right, so this system here, okay, this S-type link that couples the toggle link to the main spring through this receiving end over there, okay? This is the one on retraction, is essentially pulling up on the mainspring, and that momentum is absorbed by that energy by the mainspring, which would later supply that energy to bring the whole upper into the forward position. Now remember, this link is not, this is not independent. This is part of the total mass of the upper, and there's the main axle here, toggle pin, that that keeps it there. So any motion in the toggle, really, when the mainspring acts on this link, it's really, some of it goes into the toggle that it's breaking or expanding, and then some of that also force is acting on the barrel extension as well. So those are not two separate masses. They're really one mass, but there's a complication where at some point this mass starts to have some angular momentum relative to the barrel extension, and in fact, upon recoil, the barrel extension does not really move all the way and have a stop, okay? It still dynamically can move, it can maybe slide a little bit forward with this whole system, and then get last contact in here, the log contact thing here, upon the full recoil. So what happens, if you look down here, you see that there is still some gap, about 1.5 millimeter gap, even when this the toggle is in this position. So the toggle, the barrel extension really hasn't been stopped during this motion. It's not completely stopped yet, okay, by the log. Maybe it reached it, depending on the complexity of the dynamic that, statically here we cannot capture. We have to really fire the weapon and have a very slow, camera video capturing to see what happens. In fact, there is a video out there that I'll mention in a minute. So what happens, the reason that we have a soft collision over here, like sort of soft landing, is that the last part, squeezing part, is going to be the frame sandwiched between the back of this link. So it reaches it, it's forcing on it. And then the front, the back of the receiver log pushing on the frame. So it's like a sandwiching, clamping effect, and it would be more, and everything is under very tight resistance from the mainspring, so that really slows the process down, and really it's going to be a very soft collision, and it's not a hard collision, and it comes in later. That means that final collision doesn't happen. Okay, let me demonstrate with this. So this is the first about 6 millimeters of recoil, and then the toggle ears hit the ramp, and now pop, the ramp pops up. This is the beginning of the motion, angular motion of the toggle link, and now you see what happens. So this is the first stage. The second stage is this is going to move the remaining 4.5 millimeters. So 6 millimeters, remaining 4.45 millimeters. And then the toggle would move. But actually, that doesn't happen. This remaining 4.5 millimeters doesn't happen and give you this strong click. And this is very fortunate, very, very good, and gives a really some elegant dynamics, complicated dynamics of the Luger toggle system. Meaning that as this starts to move up, okay, it's going to act compress the mainspring harder. And as it does that, part of that force is going to be also applied, to the frame to keep it from moving all the way back and hitting the log, that sound we heard. Okay, so we saw that in here, and the sandwiching effect, and that essentially what this is telling us is that there's really a coupling motion. It's not a binary motion where you have the barrel extension essentially move back, toggle, unlock, and then the barrel extension sits there. No, it's gonna basically sort of be, as the toggle pushes back, maybe this eases off, maybe by a fraction, like a half millimeter up to a millimeter, or whatever. That depends on the stiffness of the mainspring. And the remaining and the final collision happens when this toggle is all the way back, and you get that sandwiching effect, gentle sandwiching effect that I mentioned earlier. Okay, so there's a video out there by Forgotten Weapons, by Ian. It's out there, and if you search YouTube slow motion Luger, you would see it. And it's very interesting. It's really what shows us is that you have you have that complex dynamics I mentioned. You can see it in the slow motion where this you fire around, this starts moving back, okay, and the toggle breaks and keeps moving back. And as you see, as it's moving back, this thing is now, you see it here under the, statically moving this. You see, as the toggle breaks, you can see that additional motion of the barrel extension, barrel relative to the frame. You see, it happens as the toggle breaks and the toggle goes all the way. When it goes all the way, you have that squeezing effect, and you have the max reach of the upper, essentially, and if need to, gently landing on the frame here, the log, and stopping the backward motion. So it comes in two components acting together: the soft landing here, squeeze, and the squeeze between the log and the frame at that final stage. All right, so the actual dynamics you see in that video by Forgotten Weapons is that the if you watch it carefully, is that the upper is going to move as you should move, and then it's like a double take. Then it kind of very slightly moves very slightly forward, and then finally all the way back. Okay, so there's a very interesting dynamics going on that can only be seen under slow motion of actually firing around. All right, I hope you have found that interesting. I know it's a little bit complex to explain it, but I tried my best. I hope you found it useful. Thank you for watching.